Hi everybody and welcome. In today's video we're going to put all of our pieces together for graphing parabolas. So the goal after watching today's video will be to look at a variety of different quadratic functions in different forms and be able to solve for each of the things necessary to graph them by hand and also understand what they look like when we look at the graphical image as well. So the first word that we're going to take a look at today is a bit of review: zeros. So this can be something that can be confusing when we see it asked for. It's like, what are the zeros of the function? So this is just a quick reminder for us that when we're solving for the zeros, these are the points where a quadratic function intersects the x-axis. So again, key for this, not anything crazy, it's just a different way of writing the x-intercept. So if we're looking at our graph here, we have a parabola like so. We would see our zeros would come here and they would come here. That's where the function crosses the x-axis. Now remember though, a function like this does not cross the x-axis, so it doesn't have zeros. So what happens when we see a function like this? Well, our zeros are imaginary. So if you ever see a negative square root, that's what the function is describing. It crosses in the imaginary space, so we don't actually physically see it on our graph. So if we're looking through here, graphing our quadratic equation using Desmos with a, b, and c, we'll be able to use that to check the work that we do by hand. So the first thing that we're going to do is punch this in and draw our graph. So starting off with x squared minus x minus 6. So a couple of things that we'll see on this one, we'll have zeros at -2, +3, and a y-intercept at 0, -6. We'll also have our vertex, the bottommost point of our function, is at 0.5, -6.25. So doing this by hand, if we just have those three things defined, that's enough to be able to look through and graph this accurately. Now, not a perfect graph, but to draw a sketch. So there's our y-intercept, there is our x-intercept, and we also have to note where the vertex is, which is just a little bit past that y-intercept. That's important to note because our y-intercept is not the bottommost point, it does go just a touch below it. So as we do this and we go through this graph, passing through each of our points, and it can be tricky to kind of make these things work. And again, it's not looking for a perfect graph, just as long as we are sketching this out and defining it. So if you ever make a mistake when you're drawing a graph and it's not exactly perfect, the best way to kind of cop out is just to label. As long as you label those things on the image, your math teacher will know exactly what you're talking about, even if it's not me in the future. It's good practice. So based off of that, we have a good graph of this. Now for each of these things, if we're not sure of the graph and we don't have tools to graph them, well then we simply have to go through and do it all by hand. So to find the y-intercept, plug in, that's maybe the worst asterisk I've ever drawn. So let me try that again. So we want to plug in x equals 0. So we go back to our initial equation, and we plug in everywhere we see an x, we'll plug in 0. So 0 minus 6, which is just -6. So we have a y-intercept at 0, -6, which by hand, that matches what we see on the graph. That's a great start. For the x-intercepts, we have like 3 different ways that we can solve these. So we can factor, we can use quad form, and we can also complete the square. To be honest, it really doesn't matter. We did quad form and completing the square last week, so we'll do factoring now just to review an old method, but if you prefer any of the other ones, feel free. Jump in, use those ones instead. So factoring, first and last are still the first and last terms, so x squared and negative 6. List out all of the different ways that we can get to 6. Because we have a negative sign with that 6, we'll keep it negative in between our numbers as well. We'll get 5 and we'll get 1. And our center term, our b value here, is a 1, so we're going to use that one. So we'll use 3 and 2 as our numbers. Now I just have to be careful to make sure that we're accurately doing this. Our center term is negative, so that means our larger number gets the negative sign. Our other number stays positive. So negative 3x, positive 2x. So minus 3 and plus 2 does give us negative 1. Minus 3 times 2 does give us negative 6. So we've correctly factored this into x minus 3 and x plus 2. We'll set that equal to 0 now, and that'll let us solve. So each of these things must be set equal to 0. X minus 3 is equal to 0, and x plus 2 is also equal to 0. So we'll add 3 to both sides, and we'll get x equals 3, and x equals negative 2. So by doing this, what we can see is we have, in fact, matched up 3 and negative 2 with 3 and negative 2. So also doing x-intercepts by hand, that works for us as well. So our last method for the vertex, two options. We can once again complete the square, or we can take yesterday's skill and use our formula. To be honest, the formula is a touch quicker, so that's generally what I prefer, but if you're completing the square expert, feel free to do that. So negative b over 2a, which in this case, we know that b is negative 1 and a is positive 1. We just get 1 over 2 in this case. So our x value is 1 over 2. And then we take that x value and we plug it back into our initial equation. So let's see. Our equation here is y equals x squared minus x minus 6. Because I'm running out of room, I'll use the magic of zooming to make more space. So here, if we have 1/2 squared, this turns into 0.25 minus 0.5 minus 6. Again, just punch those into our calculator. When it gets tricky, that's totally okay to do, as long as we don't get repeating decimals, because repeating means rounding, and rounding means we lose accuracy. So we have nice round decimals, so we are okay to go. And when we move through these and we subtract them again, punching it into our calculator, we get negative 6.25. And if we check that out against what we have done over here, we again get negative 6.25. So both values of our vertex check out. Looks like our method doing it by hand works just as well as looking at our graph. That's actually how your graph does it. It does all these things by hand and it lets it connect the dots. So the second way to do this is with vertex form. And when we are in vertex form, some of these options change that we have for solving, but more or less it gets us into a situation where we're still able to solve, and things do end up working out for us quite well. So to find the y-intercept, we still plug in x equals 0. So we'll just rewrite our function here, and we'll just, wherever x was before, replace it with a 0. So y equals negative 0 minus 2 to the second power. So negative, and then negative 2 squared is 4. So we'll get 5 for our x-intercept. For our y-intercept. So x is 0, y is equal to positive 5. Now x-intercepts for this one, a little bit of a different method from before. This time we plug in y equals 0. So now we'll have 0 equal to negative x minus 2 squared plus 9. And using the magic of zoom, we'll create some more space. So the quickest way to do this one actually is to add our entire x minus 2 term to the other side. So So the exact opposite of this cancels out here. We're left with 9 on the right side, and we are left with x minus 2 to the second power on the left side. So by doing this, we can now take the square root of each side. This is very similar, basically the same thing as completing the square when we use that for solving. So I would take a look back. I think it was a 4.3 notes. If you still have those, we spent an entire lesson just on doing this method of solving. And a quick reminder, if we ever take the square root of a number, it ends up with a positive and negative answer. So the square root of 9 is positive 3. So plus and minus 3, you can punch that into your calculator, or you can use the factorization of roots to get that. Either way is totally fine. And when we have square roots and squares, we cancel out the root and we cancel out the square. So we're just left with x minus 2 on this side. So if we have plus and minus, that means we have 2 equations to solve, a plus and a minus equation. Remember, it's only the 3 that's becoming plus and minus. The x minus 2 on the left side, we do not touch that side. So plus 2 on both sides. This x equals 5, and then plus 2 on both sides. This time gets us x equals negative 1. So our two x-intercepts are 5 and negative 1. Wow, that does turn out to be pretty small. So our x-intercepts here, once again, are 5, 0, and negative 1, 0. So the last piece for our vertex, we just use the 2 values that we have. So the opposite of our green, and we keep our blue exactly the same. So by doing this, we should be able to graph based off of what we have. So 0, 1, 2, 3, 4, 5 for the y-intercept. We have 1, 2, 3, 4, 5 for the x-intercept, and then negative 1 right here. So again, just double checking everything that we have so far. We're just taking what we have and we are plugging it in. The next piece is our vertex at 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have our parabola ready to graph. And a swing and a miss. Let's see if we can do this better this way. There we go. A little bit better, still not perfect, but that's the general idea here. So by using just those 3 values, y-intercept, x-intercept, and vertex, we're able to draw a pretty accurate representation of what these graphs should look like. So once again, if you have questions on solving for these 3 things from either of our methods, let us know. But now we have the skills, we are ready to work on some of those practice questions. So thanks for watching. Reach out if you need help.